Okay, a couple of weeks ago, we ended with an example involving computing probabilities from a joint PDF. And it generated a lot of questions you guys had. So I thought it would be useful if I went through another example. And this one is taken from DeGroot and Shervish's book. But I think it's a really nice example. It sort of lets me draw some sort of nice 3D pictures of what's going on, which I hope will sort of help your intuition a little bit. Okay, so suppose we have a joint PDF, little f, of x and y. And it's just equal to some constant times x squared y for these values of x and y, okay? And it's equal to 0 otherwise. Well, let's first start, before we do any kind of calculations, let's draw a picture of the support of this distribution. What is the support of a distribution? Well, it's the region of the xy plane over which there is positive probability. Okay? So just as a first step, let's make sure we understand what the support is. And how do we get from the specification of the joint distribution that I've given you here, how do we get the support? Where do we look for information on the support? Right. So it's this, this statement right here. So this PDF is non-zero for values of y and x such that x squared is less than or equal to y, which is less than or equal to 1. Okay? So the first step is all we do is draw that support. And this is what it looks like. Okay? So is that clear to everyone where that came from? So basically, I just drew the function y equals x squared, okay? Here's y equals x squared. And then I drew the line y equals 1. And the support is basically everything that's sort of contained between those two functions, okay? Okay, so this is our joint PDF. It's equal to x squared y over that support. So what I've done here is given you a 3D drawing of the actual joint PDF. I've taken the xy plane, the sort of y-axis, and rotated it down. So now it's you know, sort of on this horizontal plane along with the x-axis. So this is the support that I drew in the previous slide, okay, right here. And then the joint PDF is the surface above that describes the probability with which x and y take on various values. Okay, so how did I get this? How did I get this picture? Where did this come from? Right, so it came from the function c times x squared times y. So that's all I've done here is just taken c, some constant, times x squared times y, and drawn it over this support. Okay? Okay, so so far I haven't told you what c is, and we might want to know, because this isn't necessarily a completely specified joint PDF. How do we find c? Well, the sort of way that we, that's the sort of foolproof way that we have for finding c, is to remember that a joint PDF always has to integrate to 1. That's just a property a joint PDF has. And so if we integrate this function over the support, set that equal to 1, set that integral equal to 1, then we can solve for c. Okay, so that's just what that says. Now, note that we only need to integrate that function. We don't need to integrate this function over the entire xy plane. We only have to integrate it over the support of the distribution because outside of that support, the PDF is equal to 0. Okay? So here's what we do. I set up the integral. So here is the joint PDF. I've set up the double integral, chosen these limits of integration so that I'm only integrating over the support of the PDF, and you know, perform that integral. we get that it's equal to 4 over 21 times c, and we set that equal to 1, and so that we get c is equal to 21 over 4. Okay? So you might be a little puzzled as to how I got these limits of integration if, for instance, you haven't taken calculus in the last year or so. Maybe you've sort of are a little rusty about that. So let's take a look again at the picture of the support and see where these limits of integration come from. Okay, so here's the support, and what I'm doing is I'm integrating first out over y, and y takes on values from x squared up to 1. Okay, and then the outer integral is over x, and x takes on values from -1 to 1. Okay, and I could have done the integration in the other order as well, and that would have worked just fine.